Today we're going to solve equations that have variables on both sides of the equal sign, and you just follow the same rules that you always have. So whatever you do to one side of an equation, you have to do to the other side. So your goal is you're going to use addition and subtraction to get all of the variables with their numbers on one side, and then the numbers that don't have variables or the constants to the other side. So looking at number 1, I see a 5a and a 9a on opposite sides of the equal sign, so I'm going to pick one, and it doesn't matter which one. I'm going to pick the 5a. I'm going to decide to move the 5a to the other side of the equal sign, so since it's positive over here, I'm going to subtract it, because that will cancel it out on the left side, because 5a minus 5a is 0, and then whatever I do to the left side of the equal sign, I have to do the right side. And I can only do it to the like terms. I can't add that to a 2. So the left side, the 5a's cancel out. We are left with a negative 18 on the left. 9a minus 5a is 4a. And then minus 2. So since I decided to put all the a's on the right side of the equal sign, then all the numbers that don't have a's attached to them, I'm going to move to the left side, which means I have to cancel out that minus 2 on the right side by doing plus 2. That's going to cancel it out. I go to the other side of the equal sign and I do the same thing. Negative 18 plus 2 is negative 16. Bring down my equal sign, bring down the 4a. The 2's on the right side canceled out. And my last step, this is just a one-step equation now. So divide both sides by the coefficient of a, and a equals negative 4. Negative 16 divided by positive 4. So let's do the same thing on number 2. So again, you can choose which way you want to go with everything. I'm going to do the opposite on this one. I'm going to put all the w's to the left side of the equal sign. Last time I put all the variables to the right side. So since 8w is positive, I'm going to subtract it. So I'm going to go over to the left side of the equation, subtract 8w from the other w. These guys cancel out. So negative 2w and negative 8w combine to be negative 10w, because they're same sign, add and keep, plus 15. Bring down the equal sign, and on the right side, the 8w canceled out. I still have a negative 3. And so now, since the w's are on the left side, I'm going to move all the numbers or constants to the right side. So I've got to get rid of that plus 15 by subtracting 15. Opposite. Do the same thing to the right side of the equal sign. The 15's over here cancel out. So we still have negative 10w on the left. When I combine negative 3 and negative 15, they're the same sign, so I add and keep the sign. So negative 18 divide, and this doesn't divide nicely, so I'm going to just make it into a mixed number. So w equals 10 goes into 18 once with 8 left over, so 1 and 8/10, and it is positive because it's a negative divided by negative, and that reduces to 1 4/5. Let's do one more. So now we've got a little bit more to do. So I see some parentheses on the left side, so we have to start with distributive property. So negative 3 times h is negative 3h. Negative 3 times negative 4 is positive 12. On the right side, I think I can combine these guys. Those are like terms. They're just constants. So negative 12 plus 14 is positive 2, so I have 7h plus 2. Okay, now we can start moving. I'm going to get the h's to the right side because that's going to give me a nice positive number over there. So I'm going to get rid of negative 3h by adding 3h. Go over here and add 3h. Cancel those. So positive 12 equals 7h plus 3h is 10h plus 2. And now I'm going to move the numbers without letters to the opposite side. So I'm going to get rid of plus 2 by subtracting 2. Subtract 2. So on the left side I have 10. 12 minus 2 is 10. On the right side I'm just left with my 10h. And last step is divide by the coefficient. So it looks like h equals 1. Okay, on the bottom, the last two I want to look at is sometimes we do this and the variable actually cancels out, meaning they both end up being zeros. So let's look at number 4. So obviously we know what's going to happen, but let's walk through the steps anyway. So I'm going to combine like terms on the left side. I have a 9a minus a 1a, so I have 8a plus 10 equals 12 plus 8a. Nothing to do on the right side. So when I go to do my a's and get them together, it doesn't matter which one I pick. They're both positive, so I'm going to be subtracting an 8a from both of these. Well, that's going to make them both equal 0. So they are gone. And let's look at what we have left. So we're left with something that says positive 10 equals positive 12. Well, I know that's not true. So I'm going to turn this into not equal. It's not true. So what this means is we're not going to have an answer. We can't come up with a equals anything because there is no answer. So this is what we say. We say there is no solution. Now that's not always the same thing though. So we're going to look at the next one because something a little bit different happens. So let's do our distributive property, practice that. So 4 times d and 4 times positive 3. And on the right side, I'm going to combine these. So we've got a negative 2d plus 6d. Subtract, keep the sign in the higher number. So we've got positive 4d and a positive 12. It doesn't matter which order I write this. I'm going to write it that way. And you can already see those are equal on either side, aren't they? So we can go through this whole process again, or we could stop here, but I'm going to go through a little bit of the process. I can see that these are going to cancel out on both sides. So I no longer have any d's. I shouldn't be writing any d's in my equation at all. So all I've got left is 12 on the left side, 12 on the right side. Now that is true. 12 does equal 12. So instead of no solution, what this actually means, it's like almost the opposite. It means that every single number works. I can say d equals anything I want to, but I don't want to just pick random numbers. I need to tell somebody that, you know what, there are infinite solutions, meaning any number you want to try, if I plug it into both sides and into those d's, it's always going to come out to equal on both sides. So normally you're always going to get an answer like you have been when you solve equations. You always get a variable equals some number. But now that we see variables on both sides, sometimes they cancel out. Only when they cancel out is it one of these two. It's either no solution or infinite, and you have to decide depending on what is left on either side. If they're equal, it's infinite. If they're not equal, then it's no solution.